In today's session, we shall be discussing electromotive force, internal resistance, terminal potential difference, and loss volts. Now, the first one is electromotive force. What is electromotive force? This is defined as total work done in driving 1 coulomb of electricity round a circuit. It is a measure of the potential difference across the terminals of a cell when it is an open circuit. An open circuit means when it is not delivering current to an external resistance. It is measured in volts and has the symbol E. So we are saying electromotive force is the PD when the cell is not delivering current to an external resistance. The symbol is E. The next one is what we call the internal resistance. The internal resistance is the opposition to the flow of current by the cell when it is discharging current to a circuit. Please, we all know that anytime we hear the word resistance, resistance means opposition to the flow of current. So here, we are talking about the internal, not the external resistance. So what is internal resistance? Is opposition to the flow of current by the cell when it is discharging current to a circuit. The next one is what we call the terminal potential difference. It has the symbol V. What is terminal potential difference? It is the potential difference across the terminals of a cell when it is delivering current to an external resistance. It is measured in volts. And what is the formula for our terminal potential difference? Our terminal potential difference V equals IR. V is the capital B, I is the current, then R is the resistance. The last one is what we call the loss volt. What is the loss volt? The loss volt is the potential difference across the internal resistance of a cell. And the formula for loss volt, small v equals to I multiplied by small r. So we are saying terminal volt is for external resistance, while loss volt is for internal resistance. Loss volt is the potential difference across the internal resistance of a cell, while terminal volt is the potential difference across the external resistance of a cell. Now, mathematically, we have our electromotive force E to be equal to the sum of the terminal PD and the loss volt. What is our terminal PD? Terminal PD has a formula of IR. Then plus, what is the formula for our loss volt? I small r. From there, I is common to both sides. If you bring I out, we have E equals to I open bracket R plus R. Then we make our I the sum of formula. We have I equals to E all over R plus R. So this is the formula connecting terminal PD, loss volts, and our electromotive force. These are the terms that are very important as far as solving questions under this concept is concerned. So the first term is the electromotive force, second term is the internal resistance, the third term is the terminal potential difference, and the last one is the loss volt. Let's take some questions. Here, we have a battery of EMF 24 volts and internal resistance 4 ohms is connected to a resistor of 32 ohm. What is the terminal PD of a battery? This is Y question 1998. These are a diagram. What are the data supplied? We are given our electromotive force E as 24 volts. We are given our internal resistance R as 4 ohms. And we are given our external resistance R, big R, as 32 ohms. We are now to find the terminal PD. Terminal PD, the symbol is big V. And what is our big V? Big V equals IR. And what is this R? I equals to E all over R plus R. So we substitute that in the formula. We have V equals E all over R plus R multiplied by R. We input the data given. We have E as 24 all over 32 plus 4. 22 plus 4 will give us 36. So we have 24 all over 36 multiplied by 32. 24 multiplied by 36 will give us 768 all over 36. And when we push our calculator, we have 21.33. What is the unit of terminal volt? It is measured in volts. So our final result will be 21.33 volt. Class, I want us all to check our textbooks for more questions and solve. And I would also like us to get WAEC past questions. Take questions under this concept there and solve. They are very easy once we follow what I've explained here. Thank you.